Hi, here is the exam preparation for Calculus 1. Calculus 1 deals with one variable differential and integrals. We want to present those concepts and those type of questions that are likely to be asked on the exams. And we use the textbook Calculus by James Stewart, domain and the range of a function. We should in particular pay attention for the log and the square root. Here is the function for find the domain. Here is the answer. Inverse function and the logarithm. Pay attention, okay? This symbol is not the 1 over Fy. As textbook mentioned, we use this as x sin x equal to y equivalent to sin y equals x. And in this domain, this means for y in this region, okay? And this equivalent, okay? Okay. We give some examples. Okay. Limit x to 2 denominator approach to 0 and numerator also approach to 0. So this question, you can use L'Hopital rule. But here the question, we don't use L'Hopital rule to find this limit. Okay, the answer is 1 over 3. Okay, this is the definition of derivatives. Okay, example here. The answer is, okay, the L'Hopital rule say x0 and g0 is something 0, 0. And O something infinity, infinity. Okay, somehow this limit can be equal to, okay, so we may use this formula to get the limit. Okay, this is an example. This example very simple. Okay, the answer is we have differentiation formulas and the chain rule. Chain rule must be tested on the exam. So this is very, very important. Okay, here's the example. The answer is okay. Here is some examples. The answer tangent line. Okay, we have function, we have curve. Here, fx. The tangent line pass to this point is equation of tangent line y equal to y prime x 0 and x plus some constant c to be determined. We give 3 examples. The answer, okay, velocity can be represented by, here's the example. The answer, this is the answer for these questions. Extreme, critical point, and inflection point. If f prime x0 equal to 0, we call x0 a critical point. 2 examples. This answer, okay. Concavity test. We just memorize these 2 figures. This means concave upward. The double ply is positive. Double ply x minus mean concave downward. Newton method. So Newton method use this formula and start by x1, then pick the tangent line to find the x2. Then in the x2, take the tangent line, find the x3. Then at x3, take tangent line to the x4. Then 5, 6, we can approach to the x0, such that fx0 equal to 0. So here's the example. The example is simple. Okay, the answer now, integral. Roughly say, continuous function fx integral from a to b is the area between a and b. This is this area minus this area. And this definition of the integral, you can find the definition in the text box. We give 2 examples. The answer, okay, properties of integral. Example, we find the, so, okay, these 3 properties should be very easy to be memorized because fx bigger than gx. So area, this one and bigger than this one. We have fundamental theorem of calculus. This means the differential and correspond the integral. From the fundamental theories of the calculus, we can get a technique of the substitution. Okay, we have 2 examples. The answer is symmetrical functions. Now, integration by parts. We have 2 examples. The answer Okay, here we present the techniques to evaluate this kind of integral. You can find the technique from the James Stewart's textbooks. And this technique for evaluation of this kind of integral, and this also from the textbook by James Stewart. Here, some useful identity. It's frequently tested on the exam. So you should know very well. You can find the description in details from James Stewart's textbook. We give an example for the technique of trigonometric substitutions. Here. The answer now we give some examples. And these examples use the techniques of integration that is frequently tested on the exam. So the first example is integral fx over gx. The f, g are polynomials. The technique to evaluate the integral of rational function is described in details in the textbooks. You should find it, and you should know this technique very well. And the second, for the log. Third and fourth questions, we used trigonometric substitution. We gave the answers. Now, I have some suggestion. Okay, the subject's conception and the exams provided here may not be enough for those exams, for your final exam. If you feel some confused, if you feel some difficulties, ask your professor, students in the class or in the math help center. You should ask professors what are the formula you should memorize, and what the formula the professor provides you on the exam. Okay, thanks for watching. Bye-bye. We'll give the complete solutions of the question in this video in a couple of days. Bye-bye.